Okay, YouTube, in this video we're just basically going to confront how we can use technology to easily evaluate for the inverse trig functions of just some trig values. And so what I want to do in this video is use a calculator and radians to approximate the value, if possible, of say these three functions here. And so really quickly I just want to make a little note. Let's recall that with respect to inverse tangent, sine, and inverse cosine, we're going to see with our sine and our cosine on the unit circle, we're going to see it's going to return some angle to us between pi halves and negative pi halves. And you know, there is something to be said about this here. That our tangent value, it's really easy to forget this, but our sine value will include some angle between negative pi halves and pi halves. Our tangent value is everything up to but not including negative pi halves and pi halves. And so when we plug this trig function value in here, we're saying, hey, you know, what was the tangent, the angle that we took the tangent of to get this value right here? It's going to spit out some angle between negative pi halves and pi halves, but not including those. So what I want to put here is this. If you were to look at this in radians, because we're going to do this in radians here, your calculator is going to spit out some number here for inverse sine and inverse tangent between negative 1.57 and 1.57. Now with respect to inverse cosine, remember inverse cosine, cosine assumes all values between negative 1 and 1 on this interval from pi to 0 or 0 to pi here, and it includes those, so I'm going to label those right there. But when we do an inverse cosine, it's basically going to spit out in radians here some number between 0 and 3.14, if it's even possible to have had a cosine value between here and here, negative 1 and 1 in the first place. So when we look at arctan, let's go ahead and do this here. I've got my calculator ready to go. The first thing we want to do is make sure that our mode, let me go to mode here. Currently I'm in degrees, we want to go to radians. Quit out of this, and we're just going to hit this. Now right behind your tangent key it says tan inverse. So arctan, we know this means the same thing as tan inverse. We say tan inverse of negative 8.45. You know, maybe we had a triangle where the tangent value was negative 8.45. Then it says, well, then your angle must be negative 1.453. And I'm going to say this is negative 1.453. I just want to show you guys this here. If we were to, where'd my calculator go here? If I switch back over to, you know, degrees, and it certainly will do this for us here, and I'll just type in the same thing I've got here. It basically says you must have been a negative 83.25 degree angle if you get a tangent value of negative 8.45 over 1. So here's the deal. Going back to radians, we'll go ahead and evaluate these last two. This will be pretty quick here. We say sine inverse, we want a sine inverse, so sine inverse, clearly we don't want a tangent inverse, we want a sine inverse. We have 0.2447. So I'll type this in here. We say in radians, this would be some number between you know, negative 1.57 and 1.57 there. Enter. We get about 0.2472, and this is interesting, 0.2472, and I'm going to write this on purpose because I think I want to be clear on this. This is just an angle. This is a number of radians, okay? And then last but not least, our cosine of 2. One thing I want to point out here is this cosine unit circle, right, has a radius of 1. Cosine never gets to 2. So when we try to do this here, I just want to look at what happens when we have something that your calculator is going to complain about. So it's going to say, hey, you know, did you know that cosine's never 2? Actually, it says this. It says domain error. So basically what we're saying is with the inverse cosine function, or you know, inverse sine function also, they're never bigger than 1 and they're never smaller than negative 1. And so if you try to plug in anything in here, it's not in the domain. The domain is always from negative 1 to 1. And so we just say it does not exist. You know, 2 not in the domain of cosine inverse of x. Cheers.